welcome back in 10th English medium, chapter number 4, effect of electric current. We was continuing with this chapter, right? So today in this lecture we are going to study the different activities which are performed for the magnetic effect of electric current. So let's start now. Now magnetic effect of electric current. So when electric current flow through a conductor behave like a magnet. Now this theory was proposed by a great scientist whose name was Hans Christian Oersted. So what he told that because of the current, when the current passes through the wire, that wire behave like a magnet. This was told by the Christian Oersted. So how it is possible, how a wire can behave like a magnet when current passes. So let us understand this with his theory. So first of all, let us see the introduction of the Oersted. This experiment was done accidentally. He was performing some other experiment in his lab and suddenly he found that the magnetic needle is moving. Okay, as magnetic needle is getting deflected as the current is passing through the wire which is kept nearby the wire. So this was done. So let us first understand the some introduction of Hans Christian Oersted. Introduction to the scientist. Hans Christian Oersted, 1777 to 1851. As a scientist of the at the forefront in the 19th century, Hans Christian Oersted played an important role in understanding the electromagnetism. Electromagnetism means because of the electric current, wire behave like a magnet. This process is called electromagnetism. He observed in 1820. This experiment he performed in 1820 by accident, by chance. Okay, this experiment purpose नहीं था उनका ये experiment करने का, but by chance this experiment was performed, and then he found a great thing that when a current passes through a metal wire, the magnetic needle near the wire turns through the certain angle. As the current passes through a wire, the wire behave like a magnet, and उसके पास जो दूसरा magnet रखा था वो magnet घूमने लगा. He pointed out the relation between the electricity and magnetism. He thought that there is some relation between electricity and magnetism. Today's advanced technology is developed as a consequence. In his honor, the unit of intensity of magnetic field is termed as Oersted. So today we are using this. This is a fact in today's world that without electricity, without magnetism, we cannot use the electric energy. So these are the relation between electricity and magnetism. But initially nobody was known. He told us. So let us understand the activity which he performed. The activity which introduction which he had given, that because of the electricity the magnetism can be produced, that today's we are using in different our appliances like TV, radio, okay, all these electrical appliances, in that his principle is used today. So now let us understand one activity which he performed. What he have done, he have taken a wire, consider that wire a conductor AB, straight conductor it should be, okay. Conductor means here a wire through which the heat or electricity can pass. It could be a metallic wire. Now from that wire we have connected a cell and a tap key. You can see one connected with the battery and a tap key in a series. This is a symbol of cell and this is a symbol of tap key we have seen in table. And we have kept here one needle. This is called as a magnetic needle. There are two poles, north pole and south pole. N represent north pole, S represents south pole near the conductor. When freely suspended magnet points in the north south direction, we always know that the magnet always point towards the north and south pole, okay, when it is suspended freely. So now let us see what happened. Now in another position, if you see, same thing is there. In first position no current is passing because the tap key is not pressed, okay. Now in same cases, in second case what we will do now, key is closed so that the current will start flowing through the conductor. Now we will close the key. As soon as we close the key, the current will flow. Now you know what is the direction of flowing of the current? Yes, definitely we know the direction of current, that is from positive terminal to negative terminal. All this concept we have also studied in 9th standard, right? So current always flow from positive direction, positive terminal to negative terminal. So current will start flow from A to B. As soon as the current flow from A to B, the needle get deflect. Can you see? North pole has gone upward and the south pole has come downward. That is, it is moving in a as the current flow from A to B, the needle get deflect. So needle has a deflected in clockwise direction. This is the direction of the needle, how it is moving, that is in a clockwise direction as soon as the current flow at that moment itself. Now why does this needle deflected? This needle and this wire, they are not connected anyhow, they are kept separately, but they are near to each other. But why this needle get deflected? Needle deflect only when there is another magnet. We always know from the lower classes we have studied that if there is two magnet we kept, this is one north pole, this is one south pole, this is another north pole and this is another south pole. So opposite poles always attract, and if the two magnets are there, one magnet A and second magnet B, so they will always attraction take place between them, right? So here also there must be another magnet which attract this magnet. This is itself a magnetic needle. But is there any other kind of magnet which is kept here? No, there is a wire. So here the wire behave like a magnet and this attract the another magnet which is kept nearby this wire. That means I can say this wire behave like a magnet when amount of electric current passes through it. So hence current carrying conductor is behaving like a magnet. From this we can conclude this. After that what he have done? He have changed the polarity. Now you can see initially the battery was connected in this way, plus first and minus second. Now he have changed the polarity, he have done here plus and here minus. Bigger line is always plus and smaller line is minus, but he have changed the polarity. You can see here, okay, see in this two circle, he have changed the polarity. So direction of the current will also reverse now. Now how will the current will flow, tell me? Current will flow again from positive terminal to negative terminal, but in this case the current will reverse in this circuit. That means current will flow from B to A, right? So how does the needle is going to deflect? In this case the needle has been deflected in another position. You can see in earlier cases the needle was deflected where the north is upward and south is downward. Now in this case you see, if you see in this case the needle has deflected in such a way that the south is upward and north is downward. So what does this indicate? Now this indicates that the direction of the magnetic needle also get reversed. That means initially it was clockwise, now it is anti-clockwise. As the current flow from B to A, the needle deflects in anti-clockwise direction. So now we know that the deflection of needle is caused by current. So because of this, from this experiment we can come to know that why the needle get deflected either in a clockwise or either in an anti-clockwise direction, because the current, because the wire behave like a magnet. And why the wire behave like a magnet? Because the current passing to the wire, at that moment the wire become a magnet and it attracts the another magnet. So from this we can come to know this concept, that is about electromagnetism.